Hello, our project is about application aware routing in software defined networks. Our approach relies on the simple fact that each application generates different packets and these different packets can be routed through different routes. To demonstrate this, we use the topology as shown in the figure where different packets are sent through different routes. Here we show application aware routing using MININET. We have defined the same topology that was mentioned in the previous figure in MININET. Now the sender tries to ping the receiver. As can be seen, only S5 is sending messages. The messages from sender to receiver are being sent through S5 while all other switches remain inactive. While S5 sends the ping messages, the only things that appear on the S7 or other switches are ARP requests and ARP replies. Now we try to send TCP packets between the sender and the receiver. As can be seen, only S7 is responsible for sending the packets from the sender to the receiver, while other switches remain inactive. This shows successful completion of TCP packet transmission between sender and receiver. Now we try to send UDP packets between sender and receiver. As can be seen, only S4 is active this time, while other switches remain inactive. This shows successful completion of transmission between sender and receiver of UDP packets. Now we try to send HTTP packets between the sender and the receiver. As can be seen, only switch 3 is responsible for sending packets between the sender and receiver. The packets here are HTTP packets, while in other switches they are ARP requests and ARP replies, and hence it is seen that all other switches are inactive. Next we try to send FTP packets, and as can be seen, only S6 is responsible for sending FTP packets between the sender and the receiver. While all other switches remain inactive. The other switches only receive ARP requests and ARP replies. Previous approach routed different packets based on ports, IP addresses, and protocol type. To differentiate different packets having same IP addresses, ports, and protocol type, such as HTTP from TCP, we used a different approach in which the first packet of every flow would be inspected by the controller. The controller inspects the raw packet data and installs rules on the switches so that routing takes place accordingly. The remainder of the video shows this approach. The flows that we are going to use for this simulation are FTP, HTTP, and TCP along with ICMP and UDP. As can be seen, the HTTP and TCP flows have the same IP addresses and port numbers. So first we run the simulation with a TCP flow. As can be seen, the first packet is inspected by the controller and the other packets are then sent accordingly, without having to contact the controller again and again. Now we try an HTTP flow. As can be seen here, in spite of having the same IP addresses as the previous flow, the controller is called again to inspect the packet, and this time since it finds that it is an HTTP packet, it routes it differently. The remainder of the packets are then sent accordingly. Now we try an FTP flow, and as can be seen, the first packet is inspected again, while the remainder packets are sent accordingly through switch 6. Now we try a UDP flow. As seen previously, first packet is inspected, the remainder of the packets are then sent through switch 4. The same then happens for ICMP flow. ICMP packets are routed through switch 5. We have also created dump files for each switch. These dump files show how the packets have arrived at each switch and how they have been forwarded. The file that has been shown is the receiver file, and that shows how packets have reached the receiver.